Hi everyone, welcome back. So guys, in this video, I'll be talking about why this LLMOps is different from your traditional MLOps. So for this, what I will do, I'll just try to write down each and everything here. So first of all, let's discuss about the LLMOps. LLM ops, okay? So see, in LLMOps, the first thing we requires uh, use amount, okay? Use amount of training data, okay? Training data. So here it can be any kinds of data. It can be text, it can be image, okay, it can be audio, like that. Then we need high performance GPU and cloud resources, okay, for the training purpose or fine tuning. Fine tuning. All right. Because what happens whenever we are trying to train these kinds of large language model, this large language model has actually huge amount of let's say training parameter. I think you know that it has billions of parameter. That's why to load this model, definitely you need a higher computational system. You should have good memory, you should have good GPU, you should have good let's say resources in the system. Then you will be able to train and fine tune these kinds of model. Then uh, it requires scalable deployment. Scalable deployment. Why I'm talking about scalable deployment? Because let's say if I'm talking about chat gpt has actually lots of user, okay, it has actually millions of billions user. So if they're coming to the chat gpt, if they're using at the same time, so this kinds of application should not be go down, okay, it should not crash. That's why it should scalable deployment, and definitely it should have actually faster responding let's say time. Let's say if I'm sending any kinds of prompt, it should give me quick response, okay, otherwise people won't be using that particular product. Because nowadays we know that like time is more valuable than the money, okay. So if I'm creating any software, it should be optimized, it should be scalable, so that people will come here and they can use very easily. Got it? And it should have also continuous inference. Why continuous inference? Because I think you know that these are like conversational kinds of let's say chatbot. So here people will be talking about the questions. Nowadays actually AI agents is also, let's say, integrated with that. So if you're asking anything, it will also search over the real time, okay, on the internet, and it will give you the response. So that's why continuous inference should be there, okay. Then in the LLM ops, we also have something called biases, okay, bias, hallucination, then misleading outputs, okay. So in LLM actually we have, these are the problem, okay. And to handle these are the problem, actually we use some strategy, and we just try to utilize the LLMOps, and we usually fix that particular problem, okay. Now let's talk about the MLOps, okay, MLOps. So MLOps, you can see the first thing, this MLOps needs uh, MLOps also need actually lots of data, lots of data. But see, if you have actually less data, that time also MLOps will work, because inside MLOps what we use something called machine learning or deep learning, okay, these are the model. And in LLMOps we use something called large language model. So that's why for large language model we need huge amount of training data. But in MLOps, if you don't have huge amount of training data, it is also fine, still you will be able to train the model, okay. And most of the time you will see that this work with actually structured, tabular data, tabular kinds of data. Okay. Then second thing, the difference you can see, it requires lower compute power, lower compute power, okay, than your LLMOps, because here we use something called machine learning model, and it's a statistical model. We also use some deep learning model, pre-trained model. Okay, so as compared to LLM model, you will see that these are the deep learning model are very lightweight and very it has actually less parameter. That's why definitely you can use lower computational power to train and fine tune these kinds of models. Here I can mention, so you can perform training, training and fine tuning. Okay, fine tuning you can do. Then third thing, you can do batch processing. Okay, batch processing or periodic. Okay, periodic inference. So what is batch processing and periodic inference? See what happens in machine learning. Let's say you have built one house price prediction. Okay, house price prediction. Okay, and you have deployed this model in the production. So instead of doing the continuous prediction, how you can predict? Let's say people have given you some test data, okay, from the different house. So what you can do, you can create a batch of that data, and you can do some periodic prediction. Let's say after one day, okay, after one day you can do the prediction. Let's say whole day you have collected the data, and after evening you have predicted, you have inference, okay, and you got the results. That's how you can do the periodic inference here, okay, with the help of this batch processing, instead of doing the continuous inferencing, because continuous inferencing it's not required here. Got it. But whenever talking about actually LM powered application, here continuous inferencing is required. Okay, I hope it is clear. Then the fourth thing, you'll see this bias. We know that bias is also there inside the machine learning. Okay, so bias handling is uh, bias handling actually less complex compared to LLMs. Okay, LLMs here. So these are some actually difference I will see between these LLMOps and MLOps. Okay, that means here we are doing the same thing at the end, but in a updated way. Okay, so here we are handling large language model, that means big model. Okay, and for this we need huge amount of data, higher performance, actually computational power, scalable deployment. Okay, and we also use some strategy to handle the bias isolation and all. But in MLOps we use something called actually what I can say, let's say not massive model, but it is kinds of actually statistical model, and it's kinds of, let's say, big model, but not the massive model. So here we use other technique, like we if we have a actually less amount of data also, we can still train the model. It needs actually lower computational power. Even we can also perform the batch processing periodic inference. Okay, and handling this bias, it's very less complex, okay, compared to the LLMs. Okay, now I think this part is clear. So yes, this is all guys about this particular topic. Thanks for watching.